Now a brief discussion of the first set of problems. We're asked to construct a graph of y equals f of x equals x to the p for y factor 3/2. I assume you know how that's done, and I've done it here. The white marks here are the doublings of x, and the green is added a little bit later. So we construct the graph, we sketch the orange curve. We haven't scaled the graph yet. Then, using the assumption that y equals 4 when x equals 1, we put the point 1, 4 on the graph. And then, having done that, we scale the axes. Equal units here. Okay, that last unit's a little short, but it'll do. And equal units of 4 here. That last one's a little big, but you can improve on that. Okay, I'm not making any attempt to make this extraordinarily accurate. Reasonably accurate, yes. Extraordinarily accurate, no. Okay, that's for you to do. Your results should be better than mine if you construct the graph carefully. Now, there's a side note here, but I'm not going to talk about that just yet. This really, though, is not a graph of y equals x to the p, because if x is 1, that would make y equal to 1. So it's really a graph of like an ax to the p, and it turns out, as we see here, that a has to equal 4. So this is a graph of 4x to the p, where p is the log base 2 of 3/2. Okay, now, let's see. We're asked to make some estimates, okay? We're asked to estimate f of 2 and f of 3. How do we estimate f of 2? Well, here's just a little scratch graph to illustrate. F of 2, we go to 2 on the x-axis. We come up here, we come over to the y-axis. We find that f of 2, now on this graph, I did the same thing. I came up to 2 and over here, and I estimated that f of 2 was about 5.6. Okay? Then I did f of 3. And same thing, I came up here and over and estimated that f of 3 is about 7.8. Now, these estimates are certainly not going to be accurate to within plus or minus 1/10. In the first place, I've got a bad angle looking at this board, so I'm not sure that I'm really vertical or horizontal. The camera angle is a little weird, so you can't even tell if I'm really vertical or horizontal. On your graph, on your paper, you will have done much better. So, I get these estimates. So if your estimates were way different than this, if you estimated f of 2 equals 3 and f of 3 equals 9, then I think your graph is probably not very accurate. But if you estimated something reasonably close to these numbers and made a careful graph, did everything carefully, I expect your results will be better than mine. There's a way we can check these results. And we're not going to do that just yet, but we're going to do that in the near future. We want to do everything we can with no calculations. Okay, now I say no calculations. Okay, now, f of 3 minus f of 2. Well, f of 3 minus f of 2 is this value minus this value. Of course, we could easily calculate that from what you estimated and from what I estimated. You could calculate from what you estimate. Or I could just look at the graph. Here's where f of x, here is the value f of 2. Here's the value f of 3. How far is that? It looks like about 2 on the graph. Well, that would be my estimate. If I think this point is a little closer here than to here, I'd say maybe 2.1. If I believe my estimates, of course, I could do very simple calculation, but I want to eyeball things. I want to see things as they are, without the intermediate, without any mediation by calculation, if that makes any sense. Okay. Now, what about the solution to f of x equals 4? Well, it's a value of x for which f of x equals 4. So let's see. Here's 4, and these are the values of f of x. So for what value of x is f of x equal to 4? Well, whatever value x has when it reaches this height. So we project over here and down to here, and right there is my solution to f of x equals 4. That x value. And of course, a solution to f of x equals 10, that would require that we extend the graph out quite a bit further. I'm sorry, that doesn't. I'm looking the wrong way. Okay, f of 10 is here. We project over to the graph, we project down. I noticed this projection kind of curves up a little, so maybe I'm a little too far out. But I estimate this to be about 4.6. Now my interval between 4 and 5 is a little short, so 4.5 might be a better estimate. And this graph, this projection line, I think, cheats up a little bit, so maybe 4.3 or 4.4. But you get the idea. Okay? So I'm going to say that those are the solutions to f of x equals 1 and f of x equals 10. Okay, again, now we could check out those solutions. We can get the actual formula for this function and evaluate it using a calculator. We're not going to do that right now. Okay, then we want to estimate f of 8 over f of 2. Well, f of 8, I'd have to extrapolate a little bit. 8 is out here. We're probably going to be up about here, and that looks like about 12. F of 2, well, 2 comes up here. We already estimated that, 5.6. So we would get f of 8 over f of 2, and we can easily do that division and see that it's pretty close to 2, because this is a little less than 6, maybe a little more than 2, based on our estimates. But based on the eyeball of the graph, well, here I've got a similar graph. If this is 8 and this is 2, then here's my f of 8. Here's my f of 2. And it looks to me like if I do f of 2 and then go that much higher, that f of 8 is about twice as high. So f of 8 over f of 2 should be about 2. Down here, that according there, but according to estimates, the numerical estimates we made for f of 8 and f of 2, f of 8 over f of 2 is pretty close to 2. Maybe a bit higher. A little blurb over here. This represents a curve for y is 4 when x equals 1. So y equals 4 when x equals 1. If it's y equals x to the p, well, 1 to the p is 1 no matter what p is. If y equals ax to the p, then 4 equals a times 1 to the p, which is equal to a. That means a is 4, and our function is y equals ax to the p, with a equal to 4, so our function is y equals 4x to the p, where p is the log to the base 2 of 3/2.